So we have talked about the Pythagorean theorem. Now what we're going to talk about is what's called the converse of the Pythagorean theorem. So the Pythagorean theorem states that if a triangle is a right triangle, then a squared plus b squared will equal c squared. Or in other words, if we build a square on the leg of A and the leg of B, the sum of the squares will be the square that we can build on the hypotenuse, which is the side C. Well, the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, then the triangle is a right triangle. So let's look at this example. So it says here, is the shaded triangle a right triangle? If we look at it, we might assume that yes, it is, but we cannot make that assumption. What we must do is look at whether a squared plus b squared will actually equal c squared. So here we see that a is 4, b is 7, so a squared plus b squared will be 16 plus 49, which will give us 65. And since 65 does not equal c squared, which we found is 64, it therefore is not a right triangle. So be very careful about assuming that it's a right triangle before actually using our a squared plus b squared equals c squared formula. So we can see here that the shaded triangle is not a right triangle. I want you all to go ahead and pause the video and do this your turn. Here, what I want you to decide is, given the three sides of the triangle, so for the first one you have the A is 3, B is 4, C is 5. I want you to see if a squared plus b squared will actually equal c squared. So you're first going to say yes or no, is that going to be true? And then you're going to say yes or no, is it a right triangle? So take about 5 minutes and work through this table and then check your answer. Alright, so here we have it that all of the triangles listed will be right triangles because for each one, a squared plus b squared is equal to c squared. So when you were working, make sure that you're squaring correctly. So a common mistake is to multiply that number by 2 or add it by itself. But make sure when you're squaring something, you're multiplying it by itself. So 3 squared would be 3 times 3. 4 squared would be 4 times 4. So be careful about that. Alright, let's move on. So here's another example. It says, tell whether each triangle with the given side lengths is a right triangle. So here we have a triangle with 9 inches, 40 inches, and 41 inches as the length of the sides. We have to assume that the hypotenuse will be the 41 inches because we know that the hypotenuse will always be the longest side. So we want to check it to see if it's actually going to form a right triangle. So let's go ahead and square the two legs to see if it equals the square of the hypotenuse. So we'll do 9 squared, 40 squared, and 41 squared. We'll see that 9 squared will give us 81, 40 squared will give us 1600, and 41 squared will be 1681. Well, 81 plus 1600 is 1681. So we see that the sum of the squares of the legs is going to equal the square on the hypotenuse. So therefore, a squared plus b squared equals c squared. So it is a right triangle by the converse of the Pythagorean theorem. Now let's look at example 2. So we have a triangle with side lengths 8 meters, 10 meters, and 12 meters. We will assume that the hypotenuse is 12 meters because it is the longest side. So now we're going to use a squared plus b squared equals c squared to determine if this will be a right triangle. So let's plug it in. So we're going to plug in 8 for A, 10 for B, and 12 for C. So when we do 8 squared, we get 64. 100 squared, we get 100. And 10 squared, we get 100. And 12 squared, we get 144. So if we find the sum of the leads, the squares on the leads, we get 164. And the square on the hypotenuse is 144. Well, that is not equal. So because a squared plus b squared is not equal to c squared, the triangle is not a right triangle by the converse of the Pythagorean theorem. I want you to go ahead and pause the video and do the next your turn. Then be sure to check your answer.